Okay, it's time to introduce a much meatier section than the previous two. That is rationalizing denominators when we have a binomial, meaning two terms in the bottom of our fraction. So if we're looking at that very first example, 2 minus root 3, that's our problem. The root 3 is not allowed to be in the denominator, and 2 minus root 3 is a binomial, two terms. So note that our first step on the orange sheet for binomials is to identify the conjugate of the denominator. Remember, a conjugate has the same two terms as the original, but the sign of the second term changes. So we started with a 2 minus root 3. We're going to change that to a 2 plus root 3. That's what it means to have a conjugate. And then we're going to multiply the expression, meaning the whole fraction, by 1. That should be familiar. We did that with monomials as well. And after this first example, we generally omit that step. It's just there to remind you of why we're allowed to do step 3. You can multiply any fraction you want by 1. Step 3 sets us up for what's going to be difficult about this section. We need to multiply our original fraction, this 4 over 2 minus 3, root 3. We need to multiply that by conjugate over conjugate. And my conjugate is no longer just one thing, it's a binomial, 2 plus the square root of 3. Some of you may see where this is going already. Step 4, multiply the two fractions. In the top, that's a distributive property. And on the bottom, that's a FOIL problem. So rationalizing a binomial denominator is quite a bit more work than rationalizing the monomials, the one terms from the previous section. So taking a look at the numerator for this particular multiplication, we have 4 times 2. That's going to give us an 8. And then we also have a 4 times the square root of 3. That's going to give us a 4 root 3. That's our numerator. This problem is it's kind of nice because the numerator was just a distributive property. We are going to look at ones where there's a bit more work to do there. But in this case, 8 plus 4 root 3, that numerator is fully simplified. There's nothing else that we can do there. The denominator, take this first one slow, that's a FOIL problem. We have 2 times 2, that's our first set, so 2 times 2 is a 4. Our outsides are going to be 2 and a root 3. 2 times root 3 is 2 root 3. Here's what's nice about using conjugates. Our inside terms, actually let's stick with red still. Our inside terms, that's a 2 and a negative root 3. So 2 times a negative root 3 is negative 2 root 3 because a negative times a positive is negative. And then last but not least, we have, let's go back to green, we have the negative root 3 and the positive root 3. Negative times a positive is negative. Root 3 times root 3 is 9. But the square root of 9 is going to be 3. So if you're looking for ways to save a little bit of writing in the fraction, that square root of 9 is 3. So that's always going to happen when we use conjugates. The other thing you'll notice happens here, which happened in the previous section as well, those inside and outside terms cancel. That should always happen when you're multiplying conjugates. So taking a look at what is still here, we have an 8 plus 4 root 3 in the numerator. Cleaning up our denominator, there's a 4 minus 3. Well, 4 minus 3 is just 1. So that is a fully simplified rationalizing of a binomial denominator. So again, there's more going on here than in the monomial example. I'm going to do each one of these examples as a separate video because they do take a little while and they are going to get progressively more difficult. So if any step here threw you for a loop, if you're stuck in any place, please make sure you raise your hand, ask those questions before moving on.